Are we ready? Hello, and welcome to the Pre-Calculus Podcast. I am your host, and this is episode 11.7, talking about the binomial theorem. So we're moving on from our discussion on permutations and combinations, and moving on to the binomial theorem, which we will be using some of our combination permutations. So first, let's start off with Pascal's triangle. Now, Pascal created this triangle, or wrote it down and got credit for it. Who knows who created it? And so basically what this triangle is it starts off with 1, 1, 1, 1 as a triangle, and then as it goes down it has 1 all on the outside. And then what's happening is that each number above it is being added to get the one below. So 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 3 is 6, and so on and so forth. And that's how we get all these numbers. Now, it seems very simple. Seems like nothing special about it. It's just a bunch of numbers. But it actually is very useful when we're dealing with trying to expand binomials. Okay, so let's say we have these binomials. So we have a plus b to the 0 power, a plus b to the first, a plus b to the second, a plus b to the third. And we want to expand these. Well, the first 2, 3 are fairly simple. The first one's just going to be 1. The second one's going to be 1a plus 1b. Because remember, anything to the 0 power is automatically 1. Anything to the first power, it's still itself. The next one, using our squared binomial squaring, we have 1a squared plus 2ab plus b squared. And then if we do the cube one, if you were to actually multiply that all the way out, we end up with a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, so that's what it ends up being. Now, one thing that's actually kind of interesting is if we look at those numbers, just the coefficients, not the signs or anything, but if we look at the coefficients, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, those are our first few rows of our Pascal's triangle. Now, if I were to move it on to the next one, so if I wanted to say what was a plus b to the 4th power, okay, I can continue on, and I know that my coefficients are going to be 1, 4, 6, 4, 1. That pattern ends up continuing. So if I wanted it, that was the 4th, this is the 5th row, 6th row, 7th, 8th row. So if I wanted to find a plus b to the 8th, my coefficients would be down in this row. 1, 8, 28, 56, 70, 56, 28, 8, and 1. Those would be my coefficients going across. Okay. So now the key thing here is how are the variables changing? Okay, and so here's your binomial theorem using the Pascal's triangle. So if you have a plus b to the nth power, what you end up with, you get c0 times a to the n b to the 0 plus c1 b1, yada, yada, yada. And the coefficients, so these numbers out front, are all numbers off Pascal's triangle depending on which row you're taking it from Pascal. Starting with just a single 1 is the 0 row. And so you move down from there. Okay. Now if you look at the coefficients, or not the coefficients, the variables of these, the variables end up starting out, the first one starts out at the maximum and then they decrease by 1. And the second one starts at 0 and increases by 1. So you see how you have a to the n here. That's the same power here, and then it decreases by 1, then 2, 3, until you see at the very end you have a 0, which means that a is gone because a to the 0 is just 1. And then b is just working the opposite. Okay. So using factorial notations, essentially what we're doing is we're using kind of a combination. So you can find individual pieces by using a combination for it. To find whatever it is. So if you wanted to find the very first coefficient, it would be NC0. Okay, so it'd be NC0 to find the first one, which would be 1. And then if you did NC1, it would depend on what the number is, but it would be whatever that number is, 5, 6. And then NC2 and so on and so forth. And that's to find the individual numbers. So these, you would take N, which is the row, C, and then your K. This is your location. Okay. This is your location. And N is how is which row you want from Pascal's. Okay. And so this is just the notation for it. You don't have to really know that, but that's just kind of the general writing of it. So if we want to find the k plus 1 term, so if we want to find, let's say, the fourth term of this one, of 3x plus 5 to the 7th power, we'd end up taking if we want to find the fourth term, we'd end up taking 7c3, okay, and it's because we plug this right here. Fourth term has to equal k plus 1, and then we have to find k. So that's why it's always going to be one less than it. So if we want to find the fourth term, it'd be that, and then it'd be the first term, 3x. If we want to find the fourth, that would mean that it would be 7 minus 3. And then it'd be times 5 to the third. Okay. And what we would do is we'd end up multiplying all that out. So you see there's our k, there's all of our numbers, which is what I just wrote up there, and then we'd multiply it all out. And you see we end up with a fairly large number, x to the fourth. And remember, this is nc. This would be 7c3. Okay. Again, you're doing a combination with these. It's never a permutation, so it's always a combination. But basically, you would end up multiplying everything out to get your number. Okay, so that's essentially it with this binomial theorem. Okay, there's a lot more that can go into it, especially talking about Pascal's triangle, how there's different patterns that can be formed by it. Like if you color in all the even numbers, you get a cool little design forming. Yeah, so there's different things with Pascal's triangle that can be done. So a lot more that you can dive into and look at with those. Okay. Okay. So here's your homework from this section. Make sure you do it. Please enjoy the rest of your day, and hopefully it'll be more fun than, you know, eating. I don't know. I can't close this out. What should I say to close? No, I'm not saying that. No, I did it once. It's stupid. No. 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 Just turn it off. We'll just edit.